Welcome back, ladies and gentlemen. So today we're going to be taking a look at trapezoids and kites. Now, these are two unique shapes that are different than our parallelograms that we've been talking about lately. So they have some unique properties, and they're like each of them are their own branch of the polygons or quadrilaterals family, which I will show you guys in the back of the room then. So let's take a look. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are the bases. A trapezoid has two pairs of base angles. The non-parallel sides are the legs of the trapezoid. Okay, so a lot going on here. Here is a trapezoid, which you would most likely see. Okay, you have one pair of parallel sides. These are known as the bases. Okay, and then the sides that are holding the bases up are known as our legs. So there's two legs. These are our base angles. Okay, this is a pair of base angles as well as down here. All right, and that's a basic trapezoid. Notice the distinct difference between this and a parallelogram. Parallelogram has both pairs of opposite sides parallel. Here we've got one. Okay, if the legs of a trapezoid are congruent, then the trapezoid is known as an isosceles trapezoid. This is a very specific one. If, okay, here's my trapezoid. If these sides, if legs are congruent, then it is an isosceles trapezoid. Okay, wonderful. So we have a theorem that goes along with this. If a trapezoid is isosceles, then each pair of base angles is congruent. Right? So what that means is, if I know that these legs are congruent, and here's my trapezoid again, notice I'm still always doing the parallel sides, that means the top angles are going to be the same, and that means the bottom ones are going to be the same. Okay, so if this is like, say, 120, that's 120, that would make that 60 and 60. We're also going to find out, because of parallel lines, that these two angles, I'm going to call this 1 and 2, the measure of angle 1 plus the measure of angle 2 will always equal 180 degrees. They're going to be supplementary. Here's that special word again. Hopefully we're all feeling pretty comfortable with it. Okay? Cool. All right. A trapezoid is isosceles if and only if its diagonals are congruent. So here's just one more thing for you. If I label these A, B, C, and D, we need to make sure that AD is congruent to BC. Okay? All right. Here's the good stuff. All right, so the mid segment of a trapezoid is the segment that connects the midpoints of its legs. Now, what does that mean? Well, here I've got myself a random trapezoid drawn. Okay, still parallel. All right, and the mid segment, you find the middle point of your leg. So that means those two are equal, and then I find the middle point over here. That means these two are equal, and you draw a line straight across. So this is what's known as the mid segment. Hopefully when you guys hear that, you think of the word segment, which is a line that starts and stops, and also mid means middle. All right. Now this is a very important theorem. The midpoint of a segment, the mid segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. Oh boy, what does that mean? If this is distance A, and this is distance B, and we'll call this distance C, we know that C equals 1/2 A plus B. Okay, so here's an example. If this is, say, 8, and this is, say, 12, to find C, what we do is 1/2 8 plus 12, which would be 10. Okay, so it's really simple. All right, nothing too crazy, but yeah, let's see it put to use for a little bit. Okay, so on our back, find the angle measures of A, B, C, D. All right, so first off, we're taking a look at this. This is a trapezoid because I have one side, or one pair of parallel sides. If this is 112, you see how these are the same? Since these are the same, I know this is 112, this is 112. Okay, cool. Well, now we're going to use something kind of special. We know that these are parallel. These are consecutive interior. So that means they're supplementary. All right, so I can do 180 minus 112 and get 68 degrees. That means that angle B is 68 degrees. Well, let's not overthink this. If this is 68, this has to be 68 degrees as well. Well, okay, just to double check, if I add 68 plus 68 plus 112 plus 112, I get 360, which is nice because that's exactly what I want. Okay, cool. All good there. Okay, I got my degrees, we're set. For part B, this is not an isosceles. These are not the same. So these will not be the same. But if this is 90, okay, see how straight across from it, you have to add to 180. So if I do 180 minus 90, I get 90 as well. All right, so now over here, how do I find this one? Well, it's the same idea. Here are my parallel sides. Here are my opposite angles. I can do 180 minus 132. Seems to be a common trend, I know. 48 degrees, 48 degrees. Okay, boom, got it. All right. Lastly, a little mid-segment here. The mid-segment of trapezoid is RT. Here's my RT, find the value of X. So what I can do to find X is I can go X equals 1/2 7 plus 14. Okay, so 1/2 of 21 gives me 10.5. All right. Now I did that because X was in the middle. What's in the middle for part B? Hopefully you guys can see 13 is. So 13 equals 1/2 X plus 24. Now this is a little trickier. Why did I set this up differently? Again, X was in the middle. That's why I did X equals 1/2 the outside. Middle equals 1/2 the outside. I don't like fractions, so I want to get rid of that fraction. What's the opposite of divide by 2? Well, multiply by 2. I'm going to multiply both sides of my equation by 2. That's a terrible 2, sorry. 2 times 13 is 26. This cancels out that 1/2. Okay. If I subtract 24 from both sides, X equals 2. Cool. Wonderful. All right, last part here. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. Well, what that means is I have two sides the same, but they're next to each other, and the other sides over here are going to be the same as well. All right, so it's basically like a diamond where I pull the one side and just pull it out. Okay. If a quadrilateral is a kite, then its diagonals are perpendicular. So this is kind of neat, and this actually makes a lot of sense. If I were to draw my diagonals, these in the middle are going to be perpendicular. Hey guys, you're going to need this for the homework, but if you have a right triangle, okay, hopefully you guys remember a little bit of Pythagorean theorem, a squared plus b squared equals c squared. That's going to come into play really, really soon, okay? Real simple, nothing too crazy. We'll talk about it more. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So again, here is my kite. Sorry I'm drawing it to the side like this, but just the easiest to kind of work with. Got to label these up here too, sorry. The opposite angles that are congruent are right here. Boom, boom, you're all set. Okay, so down here, find the measures of the angles in the kite math. These have to be the same, all right, across each other. So check out how we do this. 27 plus 74 gives me 101. I want these two, okay? I know 360 minus 101 gives me 259. So that's telling me that those two angles, x and x, have to add to 259. If I take 259 and divide it by 2, I get a number, 129.5. It is okay to get decimals. So that means the angle A is 129.5 degrees, and that means the angle H is 129.5 degrees. Lastly, if that's 118, this is 118 as well, straight across from each other. Okay. What are the four angles of a quadrilateral have to add to? Well, 360. So what I can do is I can say 118 plus 118 plus 81. So I can do 360 minus 317 and I get 43 degrees for the missing angle. Okay, so kites and trapezoids, we'll talk about them a little bit more. As always, keep up the good work, and good luck. We're all counting on you.